Hello guys, welcome to the university. Today we will be dealing with projectile motion. So but before anything else, please click the subscribe button and hit the notification bell to get updated whenever we post new videos, new lectures about physics, mathematics, computer programming, and probably about subjects you encountered in school. So what is a projectile? A projectile is something that you throw in a certain distinguished path, right? And it continues to move in that path using its inertia. Alright, so just like a stone, just like a ball you shoot, just like an arrow, just like a bullet, or just like a rocket that is launched in space. Alright, so those are examples of projectile motion. The only difference in this concept it has its component velocity. Alright, so like for example, you kick a soccer ball. Alright, if you kick a soccer ball, you will see that there is a certain angle at which it is projected and it will follow a parabolic path. Alright, so this is due to the horizontal and vertical component. Alright, so the horizontal component is parallel to the x-axis, which will be our x-axis, and the vertical component is parallel to the y-axis, wherein it is also the axis at which the acceleration due to gravity is in effect. Alright, these two vector components works together to produce the parabolic arc. Alright, so next is we have to identify the component vectors using a little bit of trigonometry, and that's gonna be when we are talking with trigonometry, we're going to break it into a right triangle. Alright, so here is where the horizontal component lies. So this is the relationship of the adjacent side to our angle with respect to the hypotenuse. Alright, that is we are going to use the cosine function for that, and then for the vertical component we are going to use the opposite side to the angle with respect to our hypotenuse. Alright, so in computing for the vertical and horizontal component, we are going to use the trigonometric functions. Next is we are going to solve for the Vy, or the component velocity in the y direction, and that's gonna be equal to Vy sine theta. Alright, so this is our formula. So those of you who know a little bit of trigonometry, you will instantly notice that I just cross multiply VO to the other side. So when you cross multiply VO to the other side, you will get VO sine theta is equivalent to Vy, or the velocity along the y-axis. And right now we are going to get the velocity in the x component, and we are going to use the cosine function, which relates the adjacent side to the hypotenuse, and consequently it is Vx all over Vo. And to get Vx, we have to cross multiply Vo to the other side, and Vx now is equivalent to Vo cosine theta. Alright, so put in mind that this object is still in the effect of the acceleration due to gravity in the y-axis. So you will notice that at quite some time our ball, or our projectile, will reach its maximum height and then will then fall back to the earth. So our components, the x and y axis, may have some changes. Alright, so we are going to analyze it by component. The horizontal component is always constant because there is no acceleration in that direction. Alright, so the vertical component will have changes in direction and in magnitude. So like for example, the ball is kicked with an initial velocity of 15 meters per second. At quite some time it will reach the maximum height, and there the velocity is 0. So you will see that there is a change in the velocity, and also there is a change in direction, because here the movement of the ball is generally is upward, and with respect to the angle. Alright, so that's the angle, that's your trajectory, and then it will fall down. So there is a change in the direction, upward and then downward. Alright, so next thing that we should do is to list the concepts that we have just gathered. Alright, so the initial velocity is regarded as the muzzle velocity if we are talking with guns, if we are talking with ammunitions when they are fired at a certain angle. So that is what you call the muzzle velocity, and that will be VO, or so VO is the hypotenuse if we are going to redraw a triangle. The x component is our dx, and we have just formulated the formula for that, and that is VO cosine theta right here, and then the y component is Vy, and our formula for that is Vy sine theta, and the value of the theta is the value of the angle at which the projectile is aimed or is launched. And here, since you will see that there is a distance traveled along the x-axis, you will see that the initial and final position in the x-axis has covered some distance, and we call that the range. Alright, so that is how far the ball have traveled in the x-axis. And then we have the height, which is the maximum height traveled by our projectile. Alright, so and here we also notice that the acceleration due to gravity is still in effect, so we have to use the constant 9.8 or negative 9.8 meter per second, and the time of the ball to reach the maximum height is equivalent to the time it takes for the ball to fall back to the earth. Alright, next is to derive the formula, which will be used in the study of projectile motion. So as I am always telling you guys, we have to start from the concept that we know, which is I have listed the formula that we have gathered in the study of rectilinear motion and freefall motion. Alright, so right now we are dealing with the projectile motion, but same formula will or same concepts will just be modified. So some concepts will be added up, some formula will be modified in order to fit in our current understanding of the projectile motion. So here is the relationship of the Vyf and Vyi all over time, and that is in relation to the acceleration due to gravity. And you will see that there is an amount of time allotted for the ball to reach its maximum height. Alright, so here we were going to use the same approach in finding the maximum, the time to get up. Alright, so time to get up is equivalent to Vyf minus Vyi over g. But right here, the value of the velocity at the maximum height is 0. Alright, so 0 meters per second. So the time to get up is equivalent to negative Vyi over g. But we also found out that according to our study of trigonometry and the component vectors, this Vyi, or so the upward velocity is equivalent to the y component, which is right here, right there. So that is Vyi is equivalent to Vo sine theta. So I have to substitute it right here. So it's gonna be T up is equivalent to Vo, or negative, okay, negative Vo sine theta. And the value of the acceleration due to gravity is negative. So negative divided by negative will be positive. Alright, so there's no negative value for time. So put that in mind. So you have to divide it by negative 9.8. So the answer is always positive. So this will be the formula for the time to get up in projectile motion. Alright, so you are now going to use this formula and replace the formula that we have had earlier. So I'm gonna place the formula right here. So you will see that we are starting to modify the equation every now and then. So the next question is to solve for a formula for the maximum height. So right now, because we have the time. So we are going to use this formula, d is equal to 1/2 or negative 1/2 gt squared in order to solve for the formula. So we're going to modify that and place it right here. I'm going to change d into h because we are solving for the height. Alright, so I'm going to have h is equivalent to 1/2 g times the quantity of negative VO sine theta. Alright, over g. Because here, VO sine theta all over g is the value of time. And then we have to square that. Alright, so signs goes first. So we have negative times negative, which will be positive. Alright, so we're gonna have h is equivalent to 1/2 g times VO sine theta over g raised to the power of 2. And then when we simplify this one, we're gonna have h is equivalent to 1/2 g times VO squared sine squared sine theta squared. Alright, sine squared theta. Alright, so and then you're gonna see that g here will be squared. So you have g over g squared. So you have this g will cancel out, and then 1g will remain. So your formula now will become so cancel them out right here, and then so the u formula will be h is equivalent to 1/2 VO squared sine squared theta all over g. Alright, so you will notice that this form is just equal to VO squared. Alright, so that's the muscle velocity squared times sine squared all over 2g, which is also equal to VYI, alright, to the power of 2 all over 2g. So that is how we get the formula for the maximum height reached by our projectile. So I'm gonna get this formula and place it in our currently modified formula. Alright, so you can actually use the other formula, which is a little bit complicated with respect to the y. Alright, so you can actually use d here, and later on we'll use h for this. h2 h sub 2 minus h sub 1, or y sub 2 minus y sub 1 is equivalent to dyi times time minus 1/2 gt squared. So with respect to the position, as I have told you, you can actually use 2g. Okay, you cross multiply because this formula can be modified, and we can remove t. Alright, so I've showed you the way on how to derive for that formula. If you have missed that video, I'm gonna put the link in the description down below so that you will know how this formula arrived to this one, which is 2g times the quantity of y sub 2 minus y sub 1 is equivalent to byf squared minus byi raised to the power of 2. And then this is y sub 2. If you are going to divide both sides by 2g, you're gonna see that the height or the displacement in the y-axis, if you are asked to find the height at any given point and time of the projectile, you can use this formula. You have y sub 2 minus y sub 1 is equivalent to byf squared minus byi raised to the power of 2 all over 2g. Alright, so you always remember that the final velocity on the maximum height is 0 meters per second. So this term right here will be equal to 0. So you will just have negative h, or the height is equivalent to negative byi raised to the power of 2 over 2g. So the value will be negative divided by negative, so the value will be positive. So this is also similar. Alright, so I just showed you that whatever formula you choose to modify, if you are following the same concept, you will not be lost along the way. Alright, the next thing that we should do is to find how far does our projectile travel in the x-axis, and right now we are solving for the range. So our listed formula right here is the one available for the time, or the time to get up. DO is equivalent to DO sine theta all over G. But here, the amount of the time that the ball travel is equivalent to twice the time to get up, because that's the only time the ball is right on top, and that's the same amount of time that the ball will reach the ground again. So meaning to say that the total time traveled or consumed by our projectile in mid-air is equivalent to 2p up. So since the velocity in the x-axis is not changing and it is constant, alright, so r here, our formula is r, which is the range, is equivalent to vx, alright, so the component velocity in the x-axis times the total time, which is equivalent to 2t up. So remember guys that vx there is equivalent to vo cosine theta. Alright, so here is where I get the concept. Here is where I get the permit so that I can modify our equation. Alright, so we start our derivation in using r is equivalent to vx times the t tot. Alright, total time, t sub tot is equivalent to the total time. And then put it right here, and then substitute one by one. Alright, so r, so it's equivalent to vxi, because the time to get up is twice the t up, so I'm gonna write 2t up there. Alright, so we have r is equivalent to vo cos theta, so that's for vx, times the value of 2t up, which is 2 times vo sine theta all over g. Alright, so you will see here that there are two functions involved here, the cosine function and the sine function. Alright, so you can actually multiply them to one another. You're gonna have range is equivalent to vo squared times 2 sine theta cos theta all over g. Alright, so this particular terms in the parentheses is actually a trigonometric identity. Alright, so we are going to study trigonometry to prove that this sine theta cos theta is equivalent to sine 2 theta. So this formula can be written as r is equivalent to vo squared, or the muscle velocity squared, times sine 2 theta all over g. And this formula is for finding the range of our projectile. So I'm gonna get this formula and put it right in our list. Alright, so our complete list of the formula is right here. It's time to get up is equivalent to vo sine theta all over g. The next is for the range, which is r is equivalent to the constant velocity along the x-axis multiplied by the total time. And then the vxi, or the component velocity, is equivalent to vo cos theta, and then vyi is equivalent to vo sine theta. And then the total time is twice the time to get up, and we have computed for the maximum height. Alright, formula for the maximum height, which is vo squared, or the muscle velocity squared times sine squared theta all over 2g, which is if you know your initial velocity or the y component, alright, you have to square that and divide it by 2g, and then you're gonna get your maximum height. And then the range, or the distance traveled along the x-axis, is easily found by using vo squared sine 2 theta all over g. Alright, so next is to practice. Okay, so problem solving, it's like well, there are different setup or different scenario in a projectile motion. Alright, so maybe this is the easiest. So a kicker, a goal kicker, or yeah, so a soccer player kicks a football with a velocity of 20 meters per second, and it is aimed at an angle of 53 degrees. So that's the scenario. Alright, so when you hear the word degree, you have to actually think of a triangle. Alright, so like this one. Alright, so this is the starting point, and the angle is 53 degrees, and the kicker kicks it with the velocity of 20 meters per second. And 20 meters per second will be your muzzle velocity, or your VO, or your hypotenuse. Alright? Or the result. Yeah. So from this two, we're going to look for the X component and the Y component. Alright, later on. Okay. So in part A, you are asked to find the total time the ball is been in mid-air. Alright, because you are asked to find how long is the ball in the air. So that's equivalent to the time it gets up and the time it gets down. Alright, so you know what to expect. And then in part B, right here is you are asked to find how far away does it land. So you are actually finding the range along the x-axis. And then in the last part, which is part C, you are asked to find the height of the ball. Alright, so reached by the ball. Alright, so we can start solving by actually getting the time to get up. Alright, because in part A, you are asked to find the total time, and we have reasoned out that the amount of time of the ball to get up is also the amount of time that the ball needs to go down. So we're going to use the formula from our listed formula, which is T up is equivalent to VO sine theta all over G, and yeah, we'll pick that, and we get the solution for part A. We reason out that the total time is equivalent to twice the time to get up. So I'm gonna write the formula for the total time, or use the formula for the total time, and substitute the given. Alright, so the total time is equivalent to 2 times the quantity of VO, which is known, alright, which is 20 meters per second, times the sine of the angle, which is 53 degrees. Alright, all over G. So if you're going to solve that and execute that, you're gonna have 2 times 20 meters per second sine 53 all over 9.806 meter per second squared, and the total time of travel of this particular ball is 3.23 seconds. That's great, right? So now we have the total time of travel. We can actually look for the range. All right, so we can actually use two formula, or choose among the formula that we have to calculate for the range. All right, so based from the list of our formula, we can actually use this one, which is the range is equivalent to VO squared sine 2 theta all over G. Okay, so I'm gonna choose this one and place it right here and start solving. Alright, so what is the muzzle velocity? So the muzzle velocity is also the velocity at which the kicker kicks the football. Alright, so it's given, and it has a value of 20 meters per second. And then we have to square that, so that's 20 squared is 400. Alright, so meter squared, second squared. Alright, times sine 2 theta, so sine times 2, sine times the quantity of 2 times 53 degrees. And when you solve this particular expression, you're gonna find that the range is 39.2 meters. So the ball have traveled in the x-axis by as much as 39.2 meters. So if you want to check the value, you can actually use the easiest version or easiest formula, which is equivalent to range is equivalent to px, or the velocity in the x-axis, which is constant, times the total time of travel. So Vx is equivalent to VO cos theta, and then times the total time of travel. You're gonna have range, or R, is equivalent to 20 meters per second times cosine 53 times 3.259 seconds, and you're gonna find 39.2 meters. So that means to say that we have checked the consistency of the formula and the consistency of the concept. So next is we have to find the maximum height traveled by the projectile, which is this one, the top of the triangle. Alright, so this one, the height of this one. Alright, so we can actually list the formula and choose among them, and we can easily spot what to use, and that's gonna be h, or the height, is equivalent to VO squared sine squared theta all over 2g, or this one, VYI to the power of 2 all over 2g. Alright, so I'm gonna choose this one and then start working on. I have my initial velocity, which is 20 meters per second, so there's no problem with that. I just have to substitute it right here, and I'm gonna have 20 meters per second times 20 meters per second, or to the power of 2 sine 53 degrees to the power of 2 all over 2 times 9.806 meter per second squared. And we're gonna find that when you execute this particular expression, you're gonna have height of your ball, or reached by your ball, is equivalent to 13.008 meters. Alright, so you can actually use the formula for the free fall motion right now, which is V, or H, is equivalent to 1/2 dt squared. Alright, so executing it will give you 1/2 times 9.806 meter per second squared times the value of the ball, the value of the time needed by the ball to reach the maximum height, which is 1.62 seconds. So when you execute this, you're gonna have 13.008 meters per second. That means our concept is and formula are always constant and congruent. Alright, and they jive to one another, so there's nothing wrong with our formula. So in our practice problem, which is a football player that kicks the ball with a velocity of 20 meters per second and aim at an angle of 53 degrees, we are asked to find the maximum time, or the amount of time of travel, or total time of travel, and how far the ball have gone in the x-axis, and how high it reached in the y-axis. Alright, so we're able to solve for the total time using the formula 2t up is equivalent to VO sine theta, and this is the particular solution. Alright, and the answer is 3.23 seconds. So we do not have any available manner of checking for that. Alright, but however, we were able to find the range using this formula, and this is a particular solution. And we have found out that the ball have traveled 39.2 meters in the x-axis. And checking, you can use the other formula, and it will give you the same answer. Alright, so and then you're also asked to find the maximum height, which is found using this formula, which is VO squared sine squared theta over 2g, and this is the particular solution. And you have found out that it is 13.008 meters, and you can actually find or check this if it is consistent to some other concepts like the free fall motion, and you have done it well. You have checked that when using the formula for the free fall motion, you will get the same answer or same results. Alright, so next slide. Alright, so we have found out that the projectile motion is not so different from the free fall motion, only that it has an angle involved. Alright guys, so if you have any other question, if you have any other suggestion or reaction to this video, please put it down below. Alright, so comment down below, and I will try to answer your questions, and I will read your comments in order for us to improve our service to you guys. Alright, so please give us a like, alright, and share this to your friends who needs help in studying while studying physics, while studying mathematics. Alright, so we will help you to to have good grades, and that will ensure your A plus. Alright, from this point you watch the video until you graduate. Alright, so that's a good news for everyone. So please keep on being subscribed, alright, and keep the notification bell on, Alright, so you'll be updated whenever I post or we post new videos about physics, mathematics, computer programming, chemistry, and probably about your subject matter you encountered in school. Alright guys, so bye bye and see you on my next video.